Welcome, my dear students. Welcome, everyone. Another lecture today in the MCR3U. And we'll go now to the, before we go, we have some examples into some other parts which we had before, but I will share the screen, then we'll work on these parts. Let me tell you something, just to remind you with some past facts we had before. We said if there is the discriminant is greater than 0, that means we have two intersections. If the discriminant equals 0, we have only one intersection, and this we call sometimes this, if it is like this, we call it tangent, if it's just touching the curve. And this one we call it seconds, because seconds means 2 points, but not here in this example. I'd just like we want to go now into further examples before we leave this unit 1. It's here. It's all about the how many points, like what you see here, how many points of intersection are there for the following system equation, for the following half x squared. I will just take the example, write it on the board, half x squared, half x squared plus 2x plus 2x minus 8. This is the first function. And the second function, gx, this is fx, guys. This is fx. This is fx function. And the gx function will equal, it will be shown up to you now when I make the board clear. So here, that will equal 4x minus 10, 4x minus 10. So now what I will do is I'll just stop sharing the screen, and I will go directly into the portal to watch the, so that you can watch the board. You can clearly watch the board. I think the board is clear right now. The board is clear right now. And here even the other frame of the board is clear for you guys. Now just return it back a little bit so that it will be more clear. And I just want now to know how to get this equilibrium done, how to do this equilibrium done. First thing that I will do is just to make both equations seem to be like each other. So both the equations will be the same. So this is the first point, which we will do right now. This is what we will do right now. So we'll say half x squared plus 2x minus 8 will equal 4x minus 10. Then the next step that we will do is just put all of them on one side. So once I pass this equal sign, that means I will change the signs of the others. So it will equal half x squared plus 2x minus 8. This is 4x positive. It will go to the other side with negative, minus 4x. Then minus 10 will go with positive 10. Positive 10 equal 0. You know that when we pass the equal sign, the positive become negative and the negative become positive. And I said this before. Okay, so that will equal half x squared plus 2x minus 4x. That will equal minus 2x. Minus 8 plus 10. That will be plus 2. And that will equal 0. Cool. Till the moment, everything is fine. Till the moment, everything is fine. Okay. Now, I can take the half outside as a common factor. I can take the half outside as a common factor. So if I took this half as common factor, half, if I take it as common factor, then inside that, it will be x squared, and minus 2 divided by half, that will give me minus 4. So I divide minus 2 by half, that will give me minus 2 divided by half. Look at this. I will just show it to you. Minus 2, if I say minus 2 divided by half, that will equal, I'm just here. Minus 2 divided by half. That will equal minus 2, then flip here 2 by 1. So it will equal minus 4. Because when you divide the fraction, you will flip the fraction. Means what is nomination will be the denomination, and the denomination will be the nomination. So here that will be minus 2 multiplied by 2, that will be minus 4. So here I divided minus 2 by half, that give me minus 4. Now also I have 2 divided by half, that will give me 2, the same thing, 4. That will equal 0. That will equal 0. The same root, the same thing we will do, same constraints which we did just now, equal 0. Perfect. Now I have the x squared, then this I can, because if I divided both by half, so this side by half and this side by half, so I can say like this, x squared minus 4. This is for x, guys. This is for x plus 4 minus 4x plus 4. That will equal 0, because I said here to divide both the sides by half. I divided both the sides by half. Here it is. I divided both the sides by half. Here, this is half. 1 divided by 2. Like this. So I will divide now this side and this side by this half. So this side by this half will go the half. Half by half will be 1. And 0 divided by half will be 0. Okay. Now, if I just want to factor this, if I want to factor the x, and 2, and 2, I can factor it, actually. I can factor it. But if I just want to see how many intersections I have it here, how many sections I have, so I have 2x and 2x, that will be how many sections I will have, then in that case, it's better for me to do it using the one part which is under the root, which will show me how many solutions I have. So I will say here, I know that the part of the test will equal the root square of b square minus 4ac. It will equal b square minus 4ac. Okay. Then this part, we said, if it is positive, it will equal 0. If it is negative, there is no solution. That's what we said before. Okay. I will do it here. Now we said a x squared plus bx plus c. This is the equilibrium. A x squared plus bx plus c. Hello? 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 Okay, guys. Okay, guys. So now, what is the A here? A in this equilibrium will equal 1. A will equal 1. A equal 1. And B in this equilibrium will equal minus 4. B minus 4. And C will equal 4. Let me apply now this formula for this part. B square is how much, guys? B square will be minus 4 all square, that is minus 4 AC. A is how much? A is 1, and C is 4. Even if I didn't do the roots, it will not matter, because what will happen with under the root is also what will happen with the root is not there. So that will equal 16 under the root. 16 minus 16 will give me 0. And the root of the 0 is 0, as you know. The root of the 0 is 0. So that means what? That actually means, like I said before, when I found like this, that means that I have only, because this is 0, that means that I have only one solution. We said this in the previous lecture. We said if I have a 0, that means there is only one solution, as long as it's there. If this part was greater than 0, we have two solutions. If it is 0, we have one solution. If it is less than 0, we have no solution in that case, and there will be no points. The reason I'm just saying this, because when we go to the example, like you see here, I will share the screen right now. Yeah, and right now we can share the screen again and see this example. Here we go. The example was saying what? How many points of intersection? So we have one solution here, means we have 1 point. Or there for the following system equation. So we have 1 point of intersection. So we'll have here 1 point of intersection. So we can use this relationship to show us this relationship, to show us how many intersections we have in a particular part. We'll go now into the second part today. From here in, we'll go to the second part of our work today. And we'll move to another page. Sorry about that. And I just want to take this up. Let me bring this one like this so that I can see you guys. And I will go now, right now, to another page. I will go to page 138. I did 130th. Here is 130th. The same idea. I have two equilibriums. Solve the following linear quadratic systems. So I will just put them together. Like this will equal the first one, exactly like what I did in the board. And that will equal 10x minus 1. Then I finish it. Then I put it, I factor it. Then I have two solutions here. X plus 4 multiplied by 3x when I just factor it. It becomes like this way, 3x minus 1. Then x plus 4 may be equal to 0. Then in that case, x will equal minus 4 because I will take it the other side. 3x minus 1 will equal 0. Then x will equal 1, 2, 3. So 1 divided by 3, 3x equal 1. So this x2 will equal 1, 3. So I have here, probably I have here 2 points, because when I have 1 point for y, I have 2 points also for the y. So when y equal 10, y equal 10 and multiply by minus 4, minus 1. Here it is. Let me do it for you on the board. So that it will, because I substitute in y here, then y, the point will be when x equal minus 4, y will be minus 41. And the second point, like you see here, when x will equal 1 divided by 3, then y will equal, I will substitute in one of the forms to get the other point, the point of y. So here, the same idea, exactly like what we did before in the previous example. The same idea exactly, which we did in the previous example. You do this with your hand. If you have any issues, just let me know. But yeah, so it's exactly like this one, but this is a factorable. It's factorable, so we use the factors. Okay, let me do it on the board here right now so that it will be clear for everyone. It will take 5 minutes more, no problem, but let us do it so it will be clear for everyone, because some still might be confused or something about this idea. Solve the following, solve the following equation. Solve the following equation. I will just take the equations, then I will put the board back. Give me 1 second. The first equation, y will equal y equal, we don't want this one, y will equal what? Y will equal 3x squared, 3x squared plus 21x minus 5. This is the first equilibrium. The second equilibrium is y equal 10x minus 1. All I will do is just the same ideas which I did in the previous one. I will take equal both of them together because I'm looking for the linear solution. I will put both of them together. I'll stop the share now and go back to the board so that you can see the example in front of you here. Here it is. Let me just adjust this. Sorry about that. It will take a few minutes, but to make sure that our work is okay. Okay, here we go. So I need now to solve the following equation. Solve the following equation. Y will equal 3x squared minus 21 plus 21x minus 5. And the second equation, y will equal 10x minus 1. And I will go just directly now into equal both of them together and see. Y will equal then 3x squared plus 21x minus 5 will equal 10x minus 1. The first one I equated with the second one. So here I would say, now I'll put all together in one side. As long as we pass the equal mark, then in that case, the positive will be negative and the negative will be positive. So that will equal 3x squared plus 21x minus 5 minus 10x, and the minus become plus 1. That will equal 3x squared. We don't have any other 3x squared, so it will be 3x squared. 21x minus 10x, we have here 11x plus 11x. Then minus 5 and minus 10 and plus 1. This is minus 15 and plus 1. This will be minus 14, 1, 4. That will equal. I will just go right now into, this is minus 5. And this is become, minus 5 and plus 1, this is minus 4. This is minus 5 and this is 1. This is minus 4. Okay. Then here I will go right now into decomposing this amount. So if I do this amount right now, like this, if I do it like this, if I did, and I took now, I have 3x, and I have x. So 3x and x. And I have on the other side 4. And both of them will equal 11. Yeah. So here it will be 3x, x plus 4. This one will be 3x minus 1 multiplied by, that is x plus 4. The reason I did like this is the 3x and this is x, and I need two numbers. When I multiply them, 4, this is 4, and this is 1. The multiplication of them is 4, and the total of all of them are 11. So here it will be 3x, the minus is here, and this is x plus 4. So it will look like this. It will take this figure here. When I decompose it, 3x minus 1 multiplied by x plus 4, that will give me 0. So I have now two solutions. I have 2x. Based on the x, I will get the value of y. So based on the x, I get the value of y. So now, if 3x minus 1 equals 0, then 3x will equal 1, then x will equal 1 divided by 3. In that case, I will check for the y point. I will substitute here in this equilibrium. So y will equal, if x equals third, y will equal 10 multiplied by third, okay guys, minus 1. So y will equal 10 divided by 3 minus 1. So it will equal 10 divided by 3. Here it is. 10 divided by 3 minus 3 divided by 3, because 1 equal 3 divided by 3. So it will equal 7 divided by 3. So this point will be 1 divided by 3 for x, and y will equal 7 divided by 3. And y will equal 7 divided by 3. Okay, let's go to the second one. If x plus 4 equal 0, so x here will equal minus 4. So it's the point of x. I just want to get the point of y. To get the point of y, I will substitute in this equilibrium again. In this equilibrium, y will equal 10x minus 1. Then y will equal 10 multiplied by x. X is how much, guys? Minus 4. That is minus 1. So that will equal 10 minus 4, that is 40, minus 1, that is here, 10x, this is 10x like this. So this is minus 40, minus 1, this will equal minus 41. So the point here is minus 4 and minus 41, this point. X is minus 4 and y minus 41. So I have the points now. 1 divided by 3 and 7 divided by 3, or minus 4 and minus 41. This is the solution for this example. This is the solution for this example. I will just show right now. Here we go. So like what I said here just now, here we go, and you can see solution here. I'll share the screen back. Just give me a sec. We'll share the screen back. And I showed you how this works. Here it is. So when x equal 1 divided by 3, y would equal 7 divided by 3, like what we did. And then also for y, the same thing. For the other point, y, when it equals minus 4, when x equals minus 4, the second solution, then y will equal minus 41. It's all having the same idea. So I'm just going for 2 examples for each, but it's okay. This is for you to know or to learn something about it. It's another idea. We'll go now to the expressions, and we'll go to the rational expression in unit 2. We'll go to the rational expressions in unit 2. The start of the rational expressions in this class is today, and we will go to it right now. Rational expressions. Just adjust myself here to be sitting in front of the board. Thanks, guys. So what do I mean by rational expressions? And that's what we will see right now. Rational expressions. This is the name of the lesson. Rational, R-A-T-I-O-N-A-L, expression, E-X-P-R-E-S-S-I-O-N. Rational expression. So what the meaning of rational? Means there is nomination and denomination. Like A divided by B. So this is, we call it rational expression. Now I will go to the page 138 and see these fractions, how it will work. If I just tell you right now, 2, stop share. Let us say we want to add half plus 1 divided by 8. Half plus 1 divided by 8. In that case, I will take a common factor from here. So here 8 and here 2, I think 8 will be a common factor for both of them. 8 divided by 2 will give me 4. Plus 8 divided by 8 will give me 1. So 8 divided by 2 is 4. 4 multiplied by 1 will give me 4. 8 divided by 8 will give me 1. 1 multiplied by 1 will give me 1. So all will be 4 and 1, 5 divided by 8. This is the first example. Let us go to the second example here today. Now I will just show it also to you how it will work. Let's say I have like this. 3 divided by 5 and 1 divided by 7. If I try to look for a common factor between these two numbers, there is no common factor, like the previous one. I cannot put 7 or I cannot put 1. But in that case, it's easy for me to multiply both the denominations by each other, because 5 times 7 will equal 35. So I can say 5 times 7, that will be 35. Then I will say 35 divided by 5, this is 7. 7 multiplied by 3, that will be 21. Again, 35 divided by 5, 35 divide by 5, then this amount I will multiply by 3. So this will be 7 multiplied by 3. That will give me 21. Then 35 divided by 7. And the second one, you can do it with your hand. 35 divided by 7. Then the output, I will multiply it by 1. So 35 divided by 7, that is 5. 5 divided by 1 will give me 5. Then here, I will say 5. 35 divided by 7 is 5. 5 multiplied by 1 will give me 5. So here, now, is very clear that it will be 21 plus 5, that is 26 divided by 35. That is another example on how we can do the rationals, take a common factor for the rational expressions. We'll move forward right now into another pages here in our curriculum and take some example. Let's say example like this. I will take this example. 2x divided by 3y minus y divided by 2. Okay. Let us go and see this, how it will work. Here it is. In that case, like what we did before, we'll take a common factor from the denomination here. That will equal 3 multiplied by 2, that will be 6, and y. Now I will come to 6y divided by 3y, only will be 2. Look at this. If I divide this by this, 6y divided by 3y, the y will go with the y, then 6 and 3 will be 2. 2 multiplied by 2x, that will give me 4x. Minus, this is the minus, so I will put the minus here. The second part is the 6y, I will divide it by 2. That will give me the 6y, I will divide by 2. That will give me 3y. 3y, I will multiply the 3y by y, that will give me 3y squared. You guys got it? So here it will be 4x minus 3y squared divided by 6y. There is another big figure I can put it on. I can put it like this, equal 4x divided by 6y minus 3y squared divided by 6y. Then I can say this will be 4x divided by 6y. This is divided by 2. It will be 2 divided by 3. Here, 2x divided by 3y minus 3y squared. This will be y, 3y. And this will be 1 divided by 2. So y, this is y, divided by 2. Because I have here, this is 1, this is 2, so the 2 is here. And this is y squared and y, it will be only y. Okay? That is how it looks like when we finish it at the end. The point is, this show me that I did the right part, so I can stop till here and can stop till the age, the one before this, step before this. Here it is. That will be 4x divided by 6y minus 3y squared divided by 6y. Then I will take a common factor. The 6y like this will equal 4x minus 3y squared. This to make sure that you do it right. You can also, you don't need to do this, so you can, this is the end of the example here. This will be the end of the example here. The next part of this work will go to another page. Assume that I have an example like this. Assume that I have example like this. 3 divided by 4. How about the flipping? Because some students do not know about the flip. If I say like this, just 1 second. 2 divided by 3 divided by 8 divided by 7. In that case, I have to flip. Flip means what? 2 divided by 3 multiplied by. Denomination become denomination and the opposite. So here it will be 7 divided by 8. The 8 divided by 7, I will flip it. So the 7 will come up and the 8 will go down. 2 multiplied by 7, this is 14. And 3 multiplied by 8 is 24. 14 divided by 2, that is 7. And 24 divided by 2 will give me 12. That is the end of the example. So I have to flip it and work on it. And this is another figure for exercise. We'll go to the next idea. Now, page. Here we'll go to the rules of subtraction. Now for multiplication. Let us go for examples directly here. For the multiplication, we'll go for examples. But first, let me show you the rules of multiplication before we go to some examples here. Let me share the screen and show you how we do the multiplication. So if I have now adding and subtracting. So if I product rule x of exponential a multiplied by x exponential b, that will give me x a or exponential a plus b. If it is like this, x exponential a divided by x exponential b, that will give me x exponential a minus b. Here, I will multiply the x by its own self. Here, I will subtract, since it is a function of subtract, then x of 0 will equal 1. So any x exponential 0 will equal 1. Let us see these examples here in front of me here. Let me go to some examples here as in front of me. And we'll go for the solution of these examples. Sorry about that. I think this is not clear as well. 3x power exponential 2, x plus 2, x exponential 2, that will equal 5x exponential 2. Like you see here on the board there. Let me go to some examples right now and do it here in front of you on the board based on the notes which you have. On page 144, you have an example, 3x squared plus y. You have here 3x squared y plus this one, 3x squared y plus 4x squared y. So that simply will equal 7x squared y, because it's the same. So it will be the same. If I say as example here, minus 2, another example, minus 2 x squared y multiplied by 3x cubic y squared, multiplied by 3x cubic y squared. So that will equal one amount. So here, let me show it to you like this. Minus 2 multiplied by 3, that will give me minus 6. Then x2 multiplied by x3, let me explain it here. x2 multiplied by x3, that will, when you multiply, you add the exponentials. So this will equal x5. 2 plus 3 will give me 5. So here, the x will equal x5, and the y the same thing. Y here, y multiplied by y squared. This y is for power 1. So here, y multiplied by y squared, that will equal y exponential 3. Because 1 plus 2, 1 plus 2, that will equal 3. Y is y plus 1. So this will be y3. And this is the second example for the exponentials. We'll go to further more examples about the exponentials right now and see another example for the exponential. This example, 28x power 5 power, let me see if I can see very well properly, power 5 divided by 42x. Very nice. Now I will do it like this. Now 28x power 5 divided by 42x. We said when we, just I want to explain something, when we say x is 5, power 5 divided by x, that will give me, when we divide, we subtract the power. So that will equal x plus 5 power 5 minus 1 will equal x power 4. Same thing here. So here, I will divide 28 as example. If I divide it by 14, that will give me 2. And 48 by 14, it will give me 3. Then x power 5 divided by x will be x power 4. It will be x power 4. And this is the third example. We'll go to another example right now. Sorry about that, guys. We'll go to another example right now. Just to let it be a little bigger like this. Let us say this example in front of me here, minus 2 x power 3, this is all. X power 3, the x is power 3, and all the bracket is power 2. All the bracket is power 2. Here, in this exercise, I will see about the here is the exercise like what you see it, minus 2x power 3, and all the bracket is power 2. So no problem. That means it is minus 2x power 3, that's all, to power 2. So I will say minus 2 power 2 will give me 4. x3 power 2, this 3 times 2 will give x power 6. Will give me x power 6. Here, I will multiply this one by this one. 3 times 2, that will give me 6. Okay, guys, let us see what works here. 4x power 6. It's on the slide 144. Let us see another division for an example. For x squared divided by 8x power 5. Okay. As you see here, this with this will be half. 4 divided by 4 will be 1. 8 divided by 4 will be. When we divide, we say we subtract. So it will look like this. X power 2 divided by x power 5 will equal x power 2 minus 5, which will equal x power negative 3, which is 1 divided by x power 3. So here, I will do it directly. 2 minus 5, that will give me x power minus 3. Why power minus? Because it's in the denomination. So I can say like this, I can put it like this, 1 divided by half by 2, x power minus 3. Here it is. Okay, guys, here is x3, because it's still down. When I raise it up, it will be 1.5 x power minus 3. I think it's clear. I will repeat it again. I will repeat it again. I will repeat it again. Here is the example. 4x2 divided by 8x5. So I will say 4 and 8, that will be 1 divided by half. x2 minus divided by x5, this will be x3 down. But actually it is x2 divided by x5, it will equal x2 minus 5, which will equal x minus 3. So here, x minus 3 is, and that figure, if I will put it But in that way, I will put still down. If I want to raise it up, it will be like this. Half x power minus 3. So you can put it in this form, or you can put it in this form. You can put it in this form or this form. Here it is again. 4 divided by 8. This will be half. 1 divided by 2. X power 2 divided by x power 5 will equal 2 minus 5. Then it will be x power 3 in the denomination. If I want to take it up, it will be 1 divided by 2. I want to move this into denomination. Then it will turn from x power 3 in the denomination into x power minus 3 in the denomination, like that way. You can put it in that way. And I told you why. Because x power 2 divided by x power 5 will equal x power 2 minus 5, which will be x power minus 3. You can put it in this form, or you can put it in this form. All are the same. Both of them are the same. We'll go to our next application. Same idea here you will find in page 145. The same idea you will find at page 145. In page 145, you will have this example, 12k square m 8 divided by 4k square k 5 m 5. Cool, guys. Okay, 12 divided by 4. I wish the screen show up. Okay, guys. So this 12 divided by 4, that will give me 3. K minus 3, because 2 minus 5 will be minus 3. I'm now in the denomination. Okay. M 8 minus 5, that's 3. And that's the end. So K power minus 3, M power 3. I told you, when you divide the powers, as example, A x1 divided by B x2, then you will say here A x1 minus x2. A divided by B, x1 minus x2. This is the idea. When we divide, we subtract. When we divide, we subtract. Sorry about it. Okay. We'll go to another example. 146. The same idea here. The same idea here. So you can go for any one of those. Let us go to this example. It looks very nice, and I just want to explain it in more details. It's a good one. 3xy all cubic power 3 divided by 9x4 y4. So this will equal, guys, if you see here, you guys can see the board. So that will equal, if I just want to do it, this is cubic, means multiply by itself for 3 times. 3 times 3 times 3, this is 27. X power 3 and y power 3 divided by 9x power 4 y power 4. So now I will say 27 divided by 9 that will give me 3. X power 3 divided by x power 4 will be x minus 1, power minus 1. Y power 3 divided by y power 4, that will give me y also minus 1. 3x power minus 1, 4 power y power minus 1. And I said the rule, why this rule is, and they will find this exercise on the page on the slide number 147. You will find it on the slide 147. We'll go right now into another example. We'll see the exponents. It's very important to know the exponents and the rules of the exponents. It's very important to know about the rules of the exponents. We'll see now the rules of the exponents and check it with each other right now. How we can solve the rules of the exponents. When we put under the root, like as example, if I say root of x, it's exactly x power half. The reason is why. Why? It's like this. I'm just asking why it is like this. The reason for this, because simply that was already like this. This is 1 power 1. And of course, the root of this, the root square, we don't write the square here. We don't write it. It's logically, we don't write it, but it's actually, it's 2. So if I want to do this, this will be x power 1 divided by 2. Power 1 divided by 2. And this is how it works. Okay, let me see, did you understand or no? If I say now, this is the third root for x squared. If I want to get it out, to finish it, or to get it, then it will be x power 2 divided by 3. Look, the inside divided by the outside. The inside divided by the outside. I will just go now for the rules of the roots. The root of A multiplied by the root of B will equal the root of A, B under the root. So as example, if I say root square of 5 divided by root square of 7, that will equal the root square of 35. Okay, this is the first thing about the rules. Let me go to the next slide. Just reduce the amount of this so that you can see it. And we set the root, how it will be. So no problem about this. Let us see some examples like these examples here. If I say the third root square of 8, the third root square of 8, like this, how can I work on it? It's very easy. Third root square of 8. That will equal the, like this, it will be the third, 3. When I just factor the 8 equals 2 times 2 times 2, which equal 2 times 2 is 4 times 2 is 8. So 8 equal 2 times 2 times 2, which means 2 power 3. So the third root of 8 is 2 power 3. Let's remember together the rule which I said just now is that will equal, when I get rid of the root, if I want to get rid of the root, then I will say 2 power 3 divided by 3. The inside 3 divided by the outside 3. So that will equal 2 power 1, which equals 2. So this is the third root of the 8. Another example. We'll go to more examples here in this page. Let me say the fifth root. This is 5, the root 5. Here it is. I will just put it up like this. The root 5 of minus 32. Okay. When I decompose, this is 5, guys. This is 5. Okay. When I decompose this root, it will equal here the root of 5 for minus 2 power 5. Why minus 2 power 5? Let's decompose this 32. Let's compose it. So 32 here divided by 2 will give me 16. Divided by 2 will give me 8. Divided by 2 will give me 4. Divided by 2 will give me 2. Divided 2 by 2 divided will give me 1. So this 1, 2, 3, 4, 5. So that means it's 2 power 5. But why the minus? Because we know the rules. If I say minus 2 times minus 2, if I say like this, minus 2 times minus 2 times minus 2 times minus 2 times minus 2. I think it's very clear. This minus by minus positive, by minus minus, by minus positive, by minus minus. So this will equal minus 2 when I divide 5 by 5, which equal minus 2 power 1, which means minus 2. And this is the last solution for this example. This will be the last solution for this example. So like this, I showed you how did we get it? How did we get? And how did we deal with this amount on that way? Remember, we factor the number into its basic elements. So 32 had been factored is the multiplication of 2 times itself 5 times. And why we said minus under the root? Because actually, when you multiply the 5 minuses, it will give you at the end minus 32. When you multiply these minuses together, it will give you minus 32. That's why. And how we get rid of the root? To get rid of the root, see the internal power divided by the external power. So the external power here, minus 2 power 5 divided by 5. So it will be minus 2 power 1, which equal itself minus 2. We'll move now to another slide. On page 155. Here it's the same. The rule is the same. In the subtraction, when you subtract, the same like what you did in the power. If I say here, the root of root 4 of 16 divided by 81. So this, The 16, if I decompose the 16, it will give me 2 power 4. So that will be the root square of, here it is, that will be the root square of 4 to the 2 power 4. Why 2 power 4? Because 16, if I decompose it, I will decompose it here to show you. If I say 16, 1 6, here like this, I'll just use like 10, it's better. 16 divided by 2 will give me 8 divided by 2 will give me 4 divided by 2 will give me 2 divided by 2 will give me 1. So that means 2 times 2 times 2 times 2, that means 2 power 4 like I did here. 2 power 4 here. 2 power 4 divided by all this under the root, the 81. Same thing. When we did the same thing here right now, we will do it for the 81. 81 divided by 3 will give me 27. Divided by 3 will give me 9. Divided by 3 will give me 3. Divided by 3 will give me 1. So this is 3 times 3 times 3 times 3. That will be 3 power 4. Okay, get rid now of the root. That means I will do like this, will equal 2 power 4 divided by 4 divided by 3 power 4 divided by 4. Because I divided the internal power on the power of the root. So that will equal this with this 2 power 1. 2 power 1 divided by 3 power 1. 2 power 1 is 2. And 3 power 1 is 3. 2 power 1 is 2. And 3 power 1 is 3. So the final result is 2 divided by 3. As you see here in front of you. It will be 2 divided by 3. Just we'll go for more examples. We are on the page, slide 155. I will skip into one because the others are the same example. This is a very nice example here. A very nice example is here right now. It is saying the fourth root of x squared, x cubic, y squared. The fourth root of x cubic, y squared. It's very easy, and in one step we will finish it. In very easy, and in one skip we will finish it. Here, like I said, when we get rid of this fraction, we will divide the internal power on the power of the root. So it will equal in one step x divided by 3 times 4, 3 divided by 4, y divided 2 by 4. 2 divided by 4, and x3 divided by 4. x3 divided by 4 is the same. We will not do anything because, but y divided 2 by 4 is half. So you can say like this, x3 divided by 4, y power half. X power 3 divided by 4, and y power half. And that is the end of this example. This is slide 159. This example is very nice. Y power 1 divided by 4. This is y divided 1 divided by 4, but all is applied to power 2. And multiply by y divided by minus power 1 divided by 3. This is minus, and all to power 2. Okay, that will equal y power 2 divided by 4. Y power 2 divided by 4. Multiply by y divided by minus 2 divided by 3, because we multiply this by this one. Then that will equal, we said when we multiply the same numbers, elements, and different powers, we add the powers together. So here that will equal y divided by 2 divided by 4 plus minus 2 divided by 3. But that will equal, here, y will equal y here we go, will equal y power half plus minus will be minus 2 divided by 3. That will equal y will take common factor 6 from them. Then it will be 6 divided by 2, this is 3. 6 divided by 3, that is 2. 2 times 2 will equal 4. Then it will equal, here I will put it, y power minus 1 divided by 6. Which means 1 divided by y power 6. The same thing means y 1 divided by 1 y power 6, like that way. Okay, that is another example for the moment. We'll go now to slide 170. In that slide, and we are talking now about starting restrictions, or if there is any restrictions, when we do the expressions, how to explain these restrictions, how we will explain these restrictions. So we say as example, let's see this example. I will share the screen first to show you what we are working in right now. And what do we mean by the restrictions? What do we mean by the restrictions? So if I go right now here and say, stating this, the topic is actually about the restrictions of any multiplying dividend, rational expressions, and it goes into stating restrictions. The first part is stating restriction, and that's what we work on. Restrictions means what? That I don't get definites. So as example here, state the restrictions for the following rational. State the restrictions for the following rational. I will do the first one. It's the first and the second. I will do the first and second one, and you can do the third one. So here, the restrictions means what? When I divide, I don't get 0. By understanding another meaning, let me tell you something. You know from the past that any number, positive or negative, divided by 0, that will get infinite. So the idea is, let me stop sharing the screen now so that you can see the board. Any number divided by 0 will give me infinite. I don't want this. So I want the restrictions to take out the restrictions. So as example, if I tell you find the restrictions in the following, let's go like this. Find the restriction, this word, the restriction in the following function, If I tell you like this, find the restriction in the following function. I said a function like this, x squared plus 1 divided by x minus 4 multiplied by x plus 6. So what I want to say here, in this restriction, what will make this 0? If x here is 4, so 4 minus 4 will be 0. Then we didn't do anything. We don't want 0 to be down. We need no zeros down. And the denomination, no zeros. So what will make it 0? If x equal 4 or if x equal minus 6. In that cases, if x equal 4 or x equal minus 6, then this will be 0 or this will be 0. We don't want this type. You don't know how to do it. You can do like this. X minus 4 will make it equal 0. Then x will equal, take the minus 4 the other side, x will equal 4. Here it is, x equal 4. So if you don't know how to get it only with the blink of an eye, like this, here 4 minus 4 will be 0, then x equal 4. Here, x plus 6 equal 0, then x will equal minus 6, because minus 6 plus 6 will give me 0. Or you can make it with your hands, by the way, which I'm making right now. So also the second one, x plus 6, this amount will equal 0. Then x will equal minus 6 when you take the 6 to the other side. When you move the 6 into the other side here, it will be the positive, will be minus. So the restrictions are, here it is, restrictions. X do not equal 4 and x do not equal minus 6. X do not equal 4, here it is, x do not equal 4 and x do not equal minus 6. Those are my restriction in this function. In this function right now. Those are my two restrictions. So restrictions is the one who make the denomination x's value equal the 0. When I finish it, it will equal 0. That's what I don't want. Okay. Let us take example like this. I will just show it to you here right now on the board. We'll go for the, okay, for sharing the screen. Like you see here, the example, simplifying each expression and determine any restrictions on the variables, like what you see in front of you here. So I just want to simplify the following expression and find the restrictions of the following function. And this function, we have it right now. It looks like this. 3x squared divided by yx. 3x squared divided by yx. Even without working, without doing anything. First, to simplify it means it will equal this with this, it will be 3x divided by y. But to do the restrictions, I don't do it after the simplification. I don't do it after the simplification. I do it, the restrictions, before the simplification. Before simplification. So what is the meaning of before the simplification? What the meaning of before the simplification? Here it is. I'll stop share so that you guys can see it. Here was the example. Find the restrictions in the following. First, I have to simplify it. Then after that, I have to get the restrictions. So I have 3x squared divided by yx. So the x squared and the x will be 3x, because this will be 2 minus 1, it will be 1, 3x, divided by yx means I will get the x here with one of the x's here. So it will be 3x divided by y. But to do the simplification, I will put restrictions before the simplification. Restrictions before the simplification. So the restrictions what will make the denomination from the origin of the example 0? Either y, here I will put the restrictions here, y do not equal 0, and x also, and x do not equal 0. These are my restrictions. Why? Because if any of them equals 0, then the whole amount will be 0. Then any number divided by 0 will give me infinite. And this is not the solution. So I'm saying here that this will be from the start of the beginning, not after simplification. We will go from the beginning itself. Because if you do it here, y only will equal 0. No, we have two restrictions. We have y and we have x. Both of them cannot equal the 0. Take care of this point. Take care of this point. Thank you.